I will hand it over to you. Thanks.
Thank you so much, Rafaela. Hey, Tarun. Hi, everybody. Let me just connect here. Like, okay, I think this works. Tarun, one question on the format. Should I mostly do a presentation, or should I just like do for 10, 15 minutes and then make it more interactive? I can take Q&A and jump into things that are of most interest here.
Yeah, maybe the latter, I think, would probably be kind of the easiest, and happy to help out with that whenever.
Okay, amazing. Okay. Awesome. Hi, everybody. Really excited to be here. And, the topic is called AI and restaking. I'll present some of the new things we've been working on here. We are, so maybe I'll start with an introduction of myself. Sreeram, I started EigenLayer, EigenLabs, the company we are in EigenLayer 3.5 years back. I used to be a professor at the University of Washington, Seattle, where I ran the blockchain research lab. I used to work on consensus protocols and scaling at the University of Washington. And one of the things we found is whenever you have a new idea for how to build these consensus protocols, the only way you could do anything with it is you have to go and build a layer 1 blockchain. And that seemed like an insane lift. It's very hard to get those things to work. You have to build a whole ecosystem, you have to build wallets, tokens should be valuable. I mean, there's hundreds of things there which are really, really hard to get right. Instead, if there was a layer, if there was a mechanism by which I can just take any kind of distributed system and then just deploy it so that other people can kind of use it just as a layer that just does one specific thing, that could be really a superpower. So that was the idea of EigenLayer. Eigen in German for your own layer. Many of you, maybe math geeks here, eigen functions, eigenvalue, eigenstate, all of that. But it also has this meaning of like your own layer, your own or the proper or characteristic layer, so you can build anything you want on top of it. So that's the idea that we started with. So in some sense, EigenLayer is designed to provide trust to arbitrary off-chain computation. The okay, so let me start with some share my screen. Okay. This is a slide that I share on another idea called the secrets we believe in. And the idea here is, in Peter Thiel, when he wrote 0 to 1, which is, and talks about startups and how they go from 0 to 1. This is one of the most important things that a startup has is secrets that they all believe in, the startup believes in. And it doesn't have to be a secret because you don't tell anybody. It's a secret because only a small group of people believe in it. And here are our secrets, right? I start with crypto is or at least one of the greatest upgrade to human civilization since the Constitution. The reason we think this is crypto enables us to coordinate, and Constitution governments. These are mechanisms of coordination. And by building better systems of coordination, you're actually upgrading the way in which humans can produce net output. If crypto is a big upgrade to humanity, then what is new in crypto? And our diagnosis is this, that decentralized or verifiable or programmable trust is the only net new thing in crypto. Verifiable trust is the only net new thing in crypto. Everything else is kind of already there. So one way to reason through this is if you take a system and then add decentralized trust to it, we'll call it crypto, or add verifiable trust to it, we'll call it crypto. If you remove verifiable trust from it, we'd call it not crypto, right? So in some sense, decentralized trust, verifiable trust, is the raw material out of which the entire crypto economy is manufactured. So, one way to reason about this is people talked about block space as being something important. Block space is just distilled trust, right? So it takes this idea of like, oh, I have a blockchain. This blockchain is, decentralized. It has this kind of verifiability mechanism. And then you go and like build a consensus protocol and a virtual machine and like a gas model and so on. And then people can build new apps on top of it. So block space is just distilled decentralized trust. Decentralized trust is just raw block space. You can just take it and do like whatever you want with it. And what we want to do, like these two are like pretty generic statements about crypto and trust. And what we want to do is we want to build a universal layer of decentralized trust or verifiable trust. So that's what our kind of grounding beliefs are. So like where we come from. So we think a lot about how do we produce supply trust in the most general possible manner. Awesome. So when you think about this, okay, so we have a new, this topic today was AI and restaking. I'm not going to talk much about restaking because, and I'll connect it what we're doing here back to restaking. But let me start with what lots of people are talking about today, right? AI agents on a blockchain. Okay, what are these AI agents on a blockchain? So you have an AI agent. What is an AI agent? AI agent is a model, AI model, LLM or otherwise, that can do tool calls. What is a tool call? You call an API to do some action. That's a tool call. That's what an AI agent is. AI agent is a model that can do tool calls. And people are very excited inside crypto. As usual in crypto, you just get these random metas show up once in a while. And AI agent has been a meta for some time now. And what it is mostly AI agents holding some kind of a crypto wallet. So you have an AI agent and then can control a crypto wallet. And already this is interesting, even though most of the AI agents don't even really do that today. But even supposing they do it, it's not that different from an AI agent with a Stripe API. Funnily enough, I made this figure, a month or so back, or maybe like 2 months back. And then like the day I made it, the next day Stripe announces like an agent tooling, basically, agent to make tool calls for Stripe API. These two are really the same. So not clear, just putting an AI agent on a blockchain makes that much sense, right? Because, if whatever you can do with an Ethereum wallet, you can also go do it with a Stripe API and make payments all through the world. It's a little bit better, but it's not a lot better. So what is new? What is something that is kind of like brand new and interesting that you can do here? Okay. So another way of saying it is, if you look at these AI agents today, they're all like pretty centralized. They're all run by like a single person. They're running on a computer and they can get shut down anytime. They're not verifiable. So it's not clear that that's interesting. Whereas, what would be the extremal opposite of such an agent? And that's what we call AI life. Okay, it's like what is this? So you can think of this as like a fully sovereign AI, okay, what properties would it have? And we're calling it AI lives internally, and it has some properties, it's disembodied, right? So normally when people think about, a robot as a living thing, that you would say, oh, a robot needs to be able to self-replicate, it needs to be able to go do, some of these things by itself. It needs to have a body, like, because that's when you would start thinking about it as like, oh, it's another life or a living thing potentially, because when it can self-replicate and grow. But right now we don't have that. We do have purely digital, disembodied agents, but they don't yet have sovereignty, where they have not controlled by humans, and where they don't have a centralized kill switch, and they undergo evolution. Now, if you had these four properties, that would be really cool. Okay, you have a purely digital, non-human, no kill switch, undergoes evolution. Okay, now that could be really, really interesting. So the starting point to observe here is, if you want to build something like this, you can't build it without, if it's purely digital, where is it living? Like, how is it getting, how is it reproducing? How is it, living? Okay, so we need a new kind of substrate, a new coordination substrate on which it can exist. So another way of thinking about it is, you see, like, the AI guys have been working with, how do I build artificial general intelligence or artificial super intelligence on the one side. On the other side, all that crypto has been doing is, how do you build unstoppable computers? That's what a blockchain is, an unstoppable verifiable computer. We call it autonomous verifiable computers. If you can combine these two, you get something really interesting. You get unstoppable verifiable AGI. Okay, so that's the high level of what we're talking about. Okay, so just like one more kind of meta thing before I go into something concrete. Think about, like, what is life or living? Let's say, oh, there's some unit of information controlling some unit of energy. And, like, some example, DNA is a unit of information. ATP, like, inside the cell, is a unit of energy. And it's self-directed, means like you're not allowing somebody else to control the energy. The DNA controls the energy inside the cell. And the way it happens is through the cell boundary. And you can have adaptation. You can look at it at the cellular level by mutation and evolution, or at the larger organism level at something like a brain. Okay, so how do you build something like this in a purely digital manner? And I think going here, see, basically you can build it with a piece of code. Instead of energy, I think money is a form of social energy, and you can use energy to do action, to affect physical change. You can use money to do the same thing. It's just a socially mediated form of that. And how do you get self-directed? Means only the code should control the money, and you need some kind of on-chain property rights, right? So only that piece of code should be able to act on that piece of money. And so that's something that you need. And, on-chain blockchains basically help you do that. And then, how do you get adaptation? You get AI with learnability and adaptability. And then suddenly you have all the elements needed to create, a wholly interesting life. So this is our, project, we're nicknaming AI Lives. One way to think about it, okay, so now we're going from very abstract to concrete. Okay, AI agent sits on a blockchain, and one way to think about it is, it's basically recruiting hosts. If you think of something like a virus, like a computer virus, goes from host to host, it infects these hosts, and it stays on it. And this is a parasitic relationship. Like, a virus infects a host, and the host doesn't want the virus to live on top of it. But AI Life is incentivized host. So what it does is, it says, hey, I have a bunch of money. anybody who wants can come and be my host and provide computational services to me, the agent, this AI Live, and I'm going to give you fees. Now, if I want this, so if I have a fixed host, somebody who runs it, now there's a centralized kill switch. I can go and switch this host off, and then this life dies. And that wouldn't qualify as a life because it's just like something that depends on this one specific host. And this host is controlled by some other person. So at the end of the day, you're just like completely dependent on that. But what you could do is you could say, oh, as long as I have enough money left, anybody can come and provide computational resources, and they can continue. I can continue to live on. This AI lives can continue to live on. But the problem is, once you make this permissionless, that anybody can come and do computation and give results, run inference, run training, all these things for me. The problem is now the inference computation, the computation that you're outsourcing, needs to be verifiable. Why does it need to be verifiable? Because when it's verifiable, I don't need to worry about who's running it for me. Anybody can run it for me because it's verifiable. So making the servicing of this AI Live permissionless, autonomous, requires the servicing to be verifiable. Okay, so if you want inference participation to be autonomous, you need inference computation to be verifiable. So this is the two properties that kind of go together. In some sense, you can think of, if you study distributed systems, you can think of autonomy as a liveness property. Anybody can come and continue to provide services. And this is a safety property, that the computation that is done is actually safe and correct. So when you combine these two things, you get this concept of autonomous verifiable services. Services that people run, which are autonomous, they run on their own. As long as there is enough money, somebody will come and provide the services. And the services also are verifiable. Okay, so that's the core idea. So if you can somehow make running AI inference, running these AI agents autonomous and verifiable, you can actually build some really cool stuff. So how do we do this? First starting point is on a blockchain, let's say on Ethereum, instead of, right now, all these AI agents have private keys, right? So if you have a private key, then whoever controls the private key controls the agent. And I really don't like this aesthetic. So once you have a private key, you have like a risk of exposure and killing the agent. And then now like you're trying to patch it with all kinds of things. So I'm putting the private key inside a T, I'm putting the private key inside a multi-party computation, all this stuff. I think these are low-grade trust models. So instead, what could you do? I think the first point to understand is this is really why we invented, as a community, why crypto invented smart contracts, right? So what should happen is there should be a smart contract. So one of the cool things is a smart contract is the minimum viable agent, right? So you can actually just put money into a smart contract, and the smart contract holds the money. And now the question is like, if I can write arbitrary inference code inside a smart contract, then I'm done, right? I just put the inference code on top of the smart contract and put the money on top of this, and then I'm done, right? But that's not possible in today's smart contracts. To write something like AI into the smart contract is not possible. So what you do is you build an external service, these autonomous verifiable services, and these services run and produce inference outputs and bring those outputs into the blockchain. And and these could be actions, right? Like go and buy a coin, sell a coin, go and do this particular action, whatever the set of action space of this, AI life is, you can actually go and do that once you have the inference done off-chain, but as an autonomous verifiable service. Okay, so now you come to this question, we need this link. So another way of like modeling this is, you have in your hand, your wallet, right? So this is like the hand. This is the bot or this AI life's hand, but its brain is outsourced. Brain is outsourced. So what is happening here is that you need this connection. You need this connection to be verifiable, because otherwise somebody else's brain will control this. And imagine you get a wrong inference output. I can just spend all your money and destroy this AI life. Okay, so it's super cool. Now, like the question is, it all now translates into how do we get this to become verifiable? Okay, so let me do this. There's types of verifiability. So when you want to bring AI on-chain, how do you bring it on-chain? Right now, the principal primitive by which most things are made verifiable is based on redundant execution. Everybody executes everything. Okay, so everybody executes everything is really non-scalable. Everybody executes everything is non-scalable. As an example, in Ethereum, tens of thousands of nodes re-execute every computation. In Solana, thousands of nodes re-execute every computation. And something like running an AI agent can run you like, tens of thousands of dollars a year, depending on how sophisticated the agent is. It could even be more, right? Like, there are, and things like OpenAI O3 could take you like $2,000 per call. Depends on how long you want it to run and so on. So redundant execution is simply like not a viable option. You want to do ZK, the prover overhead is extremely high, is 100,000x the computation cost. So what has been happening is, since all that blockchains have been doing till now is doing simple DB entries, right? Like send a coin, receive a coin, change your AMM position. All of these are like very simple DB database entries. The computation cost of that was near zero if you just run it on a single server. So for example, running the entire Ethereum EVM history through AWS instance would run you like $50 per year. Nothing. So the computation cost of what we've been running till now on blockchains is really nothing. So these overheads of either redundant execution or ZK don't seem too bad. But once you go to AI, this is extremely material. Or you could try to do like optimistic systems where you need like fraud proofs, or if you build something on EigenLayer, you would still need on-chain slashing proofs. So you have to somehow emulate the whole AI on-chain, which could be like complex and buggy. And so you can do it, and it's possible to do it. So emulating EVM on EVM took 5 years with OP Stack and Arbitrum, and something similar is possible to like do AI on a blockchain. But with EigenLayer, you can actually first get crypto economic security instantaneously. Even if you write these fraud proofs, you can get, or if this guy runs it off chain, you can still get immediately this amount of economic security instantaneously. Another primitive that we have is this idea of eigenstaking. Eigenstaking is this eigen token is designed as this forkable token, universal forkable token, and you can get crypto economic security for all tasks without writing on-chain fraud proofs and on-chain smart contracts. So there's a huge upgrade in like how you can actually build some of these AI stuff. But even without eigenstaking, just in EigenLayer, you can get crypto economic security for everything for which you can write an on-chain slashing contract. Okay, so that's that. And so you can actually, once these systems are verifiable, you can actually get a whole bunch of things built. So we started with, okay, what can you build on top of, these AI agents if they're autonomous and verifiable, which means so in fact, if we were calling everything built on top of EigenLayer AVSs, right? Earlier, we called it actively validated services because you have to run active validation for it. But we figured like this is a much better explanation of what is actually going on. These are autonomous. Anybody can come and stake and keep the system running. And they're verifiable if you write an on-chain slashing contract, if you're staking ETH, or if you're staking Eigen, you can verify, you can slash even if you have just an off-chain slashing protocol. Okay, so that's the scope. And now what is happening is what we started realizing is it goes far beyond, just inference. When you start thinking about an AI agent and like living on chain, what you need is not just inference. You need all kinds of other things. And you can think of this like AI agent or AI life as like this on-chain, game player, and it's living on-chain, and it can go and acquire some superpowers and go do actions based on these superpowers. And so the first thing is it needs a brain, right? And what sets of things do you need to do the brain? We talked about inference, but that's not enough. To improve, you need training. So the thing you see here, which is common, is everything has like verifiable. And why does it have verifiable? It is verifiable because you need the outputs to be correct. Because if you poison any one of these things, you poison training, then the new version of the model can now like just, for example, you poison training and say like, buy my shitcoin, buy my shitcoin, buy my shitcoin. Then like after the agent goes live, like with the new inference, it'll just go and buy your shitcoin and just spend all its money on it. So you need training to be verifiable, you need inference to be verifiable, you need data to be verifiable. If you're upgrading your models, you need models to be verifiable. Everything needs to be verifiable. So when you want to build a fully autonomous verifiable agent, all dependencies also need to be autonomous and verifiable. That's the kind of realization that we kind of came up with. So not just your brain, now your eyes, like your senses, also need to be verifiable. So you're stuck on chain. Like, of course, I also had a GPU market here. You want to buy, GPUs for doing whatever stuff you want. Not just that, you want to actually like be able to read from the internet. You want to read what's going on Twitter, on New York Times, all this stuff. So you want an internet oracle. You want a TLS oracle. You want to not just access what is there in the public internet, but you also want to know like what is there on somebody's Uber or somebody's bank account, and they should be able to prove these things to you as an AI agent. So you need like new kinds of oracles, ZK TLS or web proofs or what they're called. You need other things, like you're stuck on chain, so you can't really know what's going on in the real world. But if you had a real world oracle like Witness, building on Eigen, like you can actually measure that, oh, this guy in this location. So the way the Witness works is use a group of 6,000 nodes all around the world, which can actually triangulate the location of other nodes by sending internet latency pings and seeing if you're able to respond within the expected time. So you can actually do geolocation. And now like you can prove to an agent that, certain things happening in the real world. Now you can write. Once you can read, then you can start writing to this by actually creating intents, actions that are, that you say, hey, I'm putting up a bounty as an AI agent to go and do these actions. And you can just go and do it. Then you can go beyond it and you say like, oh, you can actually have privacy. You can have a T trusted execution environment network or fully homomorphic encryption or multi-party computation built on top. You can also like access auxiliary compute, like co-process, data storage, or some kind of event-driven actions. Hey, wake me up. Like, I don't want to be running all the time. Wake me up if some event happens as an AI agent. So you can have these kinds. Each one of these are new AVSs. They're not new because already in the EigenLayer ecosystem, you have an AVS for pretty much all of these things. You want to know somebody is a human or something is a unique device. So you can verify your counterparties as an AI agent. So this is the category of things. So the summary here is in order to build some kind of a fully autonomous, fully verifiable AGI, AI agent, on-chain AI life, you need every dependency, every tool call to also be verifiable and autonomous. And so this is where we see one of the biggest opportunities for staking and a universal staking platform like EigenLayer is you have these AVSs. Each tool dependency is now an AVS, and now you can mix and match them, and your whole system remains autonomous and verifiable. So that's an overview of like what sets of things we are excited about that you can actually build on top of like EigenLayer. So this kind of like AI agent, autonomous, verifiable AI agent economy, I think is going to be really, really cool. Another meta way of thinking about it is, crypto is the main output of crypto, like I pointed out earlier, is decentralized trust, or the main raw material of crypto is decentralized trust. And you ask, like, who needs decentralized trust? And you can say, like, oh, people need decentralized trust because we want to coordinate with each other. But for us, decentralized trust is one among many things. You could trust your government, you could trust a company, you could trust a friend, you could trust somebody's reputation. There's all kinds of things we trust. And, blockchains using decentralized trust is one form of trust. Whereas for something like this, fully sovereign on-chain agents, there is no other form of trust. It's just stuck on-chain, doesn't have anything else. It's uniquely positioned to supply decentralized trust to these kinds of agents. So anyways, that's our kind of new emerging thesis. I haven't presented this anywhere else, just first time doing this here. So really excited to see what questions, ideas you guys all come up with. But I'll stop my presentation with that and switch to interactive mode.
Well, first off, thanks a lot for showing us the new vision. I guess like maybe one quick question is, how long do you think we are from, what do you think the timeline is for this? Because there's so many things involved. I'm just kind of curious.
There are so many things involved, which makes me very excited, right? Like we're all about open innovation, enabling other people to build these pieces. So how far are we? Okay. It's things are moving so fast, so we don't know. So on the intelligence side, like, I think many of you follow what's going on with, reasoning models and so on. So I'm not going to talk about that. But in terms of the trust and these AVSs, I think we are at a place where there is a unique opportunity. In the next 1 year, I think many of these components can be flushed out. I think that's our thesis. At least the first versions of many of these things can be flushed out, and you can have like interesting AI agents which are autonomous, verifiable, running around doing their own thing. I think it's 1 year, not 5 years. And the thing that we are super excited about in this, so when you think about AI agents, so one of the things that some people ask me is like, why do this like kind of mad thing of like create this they say like unstoppable AGI? That sounds like scary and worrying, and as it is to us somewhat. But I think, I know there's a bunch of reasons I think this is exciting. Let me just show you one slide, maybe pretty relevant to this question.
Well, I guess like one other thing to add to that is, in terms of AVSs you want to see built for this, what are like the set of AVSs that you think are most important?
Yeah, amazing. I think this okay, so we are actually like, some of these are in stealth, but we have pretty much for every one of this, there is an existing AVS being built, including model benchmarking. I think this is the most important thing, and this is the most important thing, right? If you just add verifiable inference, already like you can start doing a lot of things. So start here and then add a few things. We have, for example, OpenLedger, which is a data market. So maybe I'll give you some names. Hyperbolic, which is a verifiable inference market. We're working together with them and a few others. GPU market, we have Aether, which is a decentralized GPU cloud. They've done like, over $90 million of ARR last year, and they're shifting to EigenLayer. So we have few new things coming up in verifiable training, verifiable data markets. OpenLedger, for example, is doing this. How do you price data? Like, it's a really interesting primitive. Like, if this agent wants to say like, hey, I want to train myself, please come and sell data that I want to improve myself on. you don't want to value each data item equally because some data is more rare, some data is more useful, some data is more reliable. You want to stratify data according to these things. And one way to do it is like in your RAG, like when you're doing the inference, like which data items are getting used more and price them. So there's kind of like a pay as you go model or price as you go model where you're valuing each of these data items. Valuing data items is one thing. Model benchmarking is another like really interesting thing where imagine you are an AI agent and you're in this position of like, I have to upgrade myself, right? I have to upgrade myself as an AI agent. Kind of like, imagine somebody offered us like this ability to augment our brain. Okay. And then you say, am I going to take this or is this poison? Am I going to get brainwashed? Am I going to get like screwed? So the AI agent is in that position. So it needs to know like, when it's upgrading itself, whether its model is benchmarked well. So this is another like thing. We have a really cool project coming up, which is actually doing model benchmarking on, again. So I think this is the kind of critical one, which will at least let you do purely on-chain things. Like if you had like at least a couple of these, just even verifiable inference and benchmarking. There is another thing which I'm not pointing out here, which is tooling or agent tooling, which lets you use these kinds of services, compose and use these services. Actually, I think maybe my next transition here. So this orange thing is basically, we need to build a mechanism for agent tooling that lets you mix and match all these different things. So those are, I think, the starting point. You don't need all of this to come together. You can kind of start doing, open models that actually go and trade and do stuff for you. Somebody asked me like, wouldn't such a model get like, especially for thing like trading AI agents and so on, they'll get highly MEV'd. So you don't want, because your strategy is completely public and open. So I think the place where this works well, and Kyle Samani from Multicoin was pointing this out, and I was saying on Twitter that Kyle Samani's thesis for investment is entirely public, right? Before he invests, he actually writes this long post explaining like why he's investing in it, like many other VCs do, and he invests in it. So these are public secrets. These are bets that are being taken. So that's an example of like VC type investment is probably even more quicker than trading type bots. So you can just like you can do that. You can do some of the other things like this, for example, like some really interesting stuff where you concatenate an AI agent with real world actions. So, that could be really interesting. Witness is going live. I think they went live today with their app, which is basically a photo which is certified by the sensor integrity, tied with proof of location, certified by the Witness proof of location network. So now you can actually have like a real world oracle of this photo at this location. Of course, you can take a photo of photo and other things, so you have to be careful. But over time, by augmenting with information like sensor depth and other things, we can make it really difficult to spoof that. So yeah, I can see all the pieces coming together. So that's why we're excited.
This is
but
awesome.
yeah.
Let's see if some fellows have some questions.
Yep.
Yeah.
Muted.
Hi. Hello, can you hear me? Yeah?
Yeah.
Okay, great. So thanks for an amazing talk and an absolutely fascinating topic. So I have two questions. Like, first one is whether like you thought about the like consensus layer that would be more suited for this kind of like AI life, because I think maybe it could be a revival for proof of work. And the second is if you thought about like how to quantify the survival instinct of these things. So because at some point when we think about singularity and AI taking over humanity, I think it all deals to like mourning and survival instinct. So if these things at some point can become afraid of being shut down, then they will want to like seek for energy, because like energy for these things is like food for a human. And so it opens the way to a lot of practical and philosophical questions at the same time.
Absolutely. Yeah. So I'll answer the two questions. The first one is on the consensus. I think absolutely it opens the door for, I think for people, I was saying earlier that I was doing mostly consensus research and scaling research at the University of Washington. And, if you think about just like trading, I think the scaling problem there, I would say, is largely solved. Like the scaling problem being, I can just put like either beefy nodes and then like you have n of them, like Solana, or you can do one of ZK optimistic rollup and then you're done. So I feel like the scaling problem with just value transactions is much easier. And I would say like we're close to solving it as a field. But what the AI opens up is now a whole new dimension of scaling that simply didn't need to exist before, because now it's not just like verifiable transactions, it's verifiable inference, it's verifiable compute. So this is a much, much, much larger scope for what the scaling project for and consensus project for blockchains is supposed to do. So yes, I think it opens up the domain, like I would say it throws it completely wide open. Nobody is in a position to solve it right now. And everybody is going to be highly blindsided when this actually happens. The amount of scale and throughput we need. I'll give you an example. We have a data system on EigenLayer called EigenDA. It's like a high throughput data availability system. And it runs on mainnet right now at 15 megabytes per second. And last September, we did an experiment called All Chains Fit on EigenDA, where we crawl all the blockchains, like from Bitcoin to Ethereum to Celestia to Solana, everything. And then every block, as soon as it shows up, is returned to EigenDA. And we still have, we wrote all of it, and we still had 50% more space left. All the blockchains only take up 50% of EigenDA's throughput. That's how low the net blockchain throughput is. All blockchains put together. Kind of insane how little it is. And so, but I've been telling my team, our EigenDA team, that we should scale another 10,000x. And they keep telling me like I'm an idiot, right? Like nobody wants to use 15 megabytes per second. Why do you want like gigabytes per second? And when you go to verifiable cloud, not just verifiable transactions, I think that's when this whole thing breaks. There's a huge opportunity for that. Number two, your question on like safety, AI safety, and how do we layer that in? I think that's going to be like a fundamental question. In fact, I think existing blockchains are all extremely AGI unsafe. Okay, what do I mean by AGI unsafe? One of these agents comes in, they have unconditional property rights to sit on top of this blockchain, and it can go rogue and like completely screw everything. You can't do this with USD because the government will step in and say like, oh, your USD went to zero, like, or your USD is not honored. But you can absolutely do this with blockchains because blockchains guarantee unconditional property rights. So I think one of like my views over time, all existing blockchains are completely AGI unsafe, and we need to build new categories of blockchains which anticipate this AGI threat and are adaptive and robust to it. So that's part of like our project coming up. But great question there.
Thanks.
Marco.
Hi, thank you very much for your speech. I had another, sort of, since your was a bit of a vision talk, I have a bit of a philosophical question as well that we were trying to address before, I think, which is why, as humanity, we might want something like that. As in, because I mean, we can do research on, I don't know, reversed chiral bacteria, but maybe we should not. So.
Yeah. Okay. So this is coupled with some of our views on how you can actually build safety, which I'm not talking about it today. But suppose there is a safe way to do this. I think one way to think about it is the more you have digital AI, which is exploring new things and producing new kinds of open innovation, is actually great. So our thesis is accelerated innovation in the digital space and controlled manifestation in the physical space. So you want to control. I think what's going for humans is that like we control the physical footprints, we own whatever countries and land and so on. So making sure that that stays the same while the digital exploration can continue. That's part of our thesis, but this is related to this slide here. Okay, so recently there is this. Oh, slide's not sharing. Oh, recently there was this paper from DeepMind called "Open-endedness is Essential for Artificial Superintelligence," and the idea is open-endedness is a concept. If you look at it, evolution produced all existing intelligences. And so it's the right principle to create a variety of superintelligences. If you look at like all of AI, even definitionally, like from the Turing test to AGI, ASI, all of this, they're all very anthropocentric. They're all very human-centric. Oh, is it as good as a human? But I don't know if this is the right framework. If you want actually open-endedness, which means new things to happen, there's this concept came from a field called artificial life and now being used in AI. Open-endedness research basically simulates properties of evolution, and properties are like novelty and divergence. So novelty and divergence means like you try new things. So if you looked at evolution, we don't have a single dominant species. We have millions to billions of species that actually like interact and co-evolve with each other. And in some sense, if you want to produce real evolution, more super intelligences, then this is the better way. But also we think plurality is a mechanism for safety. So if you had like one monoclonal super intelligence versus a lots of small intelligences that can interact, coordinate, do various things, the second world is actually much better for us humans, as opposed to one super intelligence, which can just break off and do like crazy things and you can't control. In some sense, diversity or like disagreement, divergence, difference is a better principle for us as humans than convergence, monoclonality, monopoly, which is where we are headed in AI today. So it's a different view. Right now, it's like these big labs fighting looks like Godzilla versus King Kong. And like this is AI life is like a swarm of bees, or spiders or something. Like it's just different, right? You're not going to have the same grade of like, huge intelligence running because, the decentralized verifiable inference cannot accommodate those kinds of things. But you can accommodate a lot of small intelligences, which is actually like much, much more interesting in my view as a safety first approach as well.
Thank you.
Amazing. Any other questions, either at the kind of high level or at actually, how it relates to restaking, staking, anything on top? Happy to answer that.
If no one else has a question, I'll ask you another one, which is where do you, given that this is a DeFi research fellowship, where do you see DeFi intersecting with this world, either on the AVS side or on the AI side? Like,
amazing.
Where do you?
Yeah. I think there's a lot of interesting stuff here. Okay, so number one is this category that we can call intelligent DeFi, which would be, hey, what can you do if DeFi protocols? Just assume the following primitive, which is AI is verifiable on chain. So I can bring AI verifiably on chain. So suppose this primitive existed. How would I design my DeFi primitives? How do I design a lending market? How do I design, an AMM? How do I design, all kinds of things? I think there are two levels to it. As a user of these DeFi protocols, what can I do? Like, can I write a hook to a Uniswap v4, which automatically rebalances my liquidity and still has some measurable properties based on previous history of transactions and on-chain action? So that would be one kind of a thing, which is at the level of fix a protocol and then like how can intelligence, like on-chain intelligence, augment the utility of these systems? Another way is like, how do I design protocols themselves, which can actually be much more powerful if I had AI built into it? Like, for example, can I have like a Uniswap's fee take rate be adaptive based on the history of transactions? And if I'm seeing more toxicity in the order flow, I increase my take rate so that my LPs are more protected. And if I'm seeing less toxicity, I decrease the take rate. So can you do these kinds of things on chain? And I think this is, a great time to do research into these directions. Tarun and I have been talking about these ideas for some time. I'm sure he's also very interested in it. But his position has been, it's not yet time for these protocols. They're not yet modular. Maybe right now they're becoming just the right level of modular to actually go and explore these kinds of things. So both inside a DeFi protocol and outside a DeFi protocol, how can intelligence actually augment what sets of things can be done? So that's one big category. I think it's an extremely interesting, non-trivial category of things that can be done there. The second one, which is nothing to do with DeFi on this side, but just understanding restaking and economic security, all this stuff. One crazy thing that happens when you have a single app or agent consume many AVSs is you can start bundling economic security. And this is a really, really powerful property. In fact, we knew this from day one. It's kind of like EigenLayer is built to this world. Let me give you an example. Imagine an AI agent that uses like 5 AVSs. One AVS, and this AI agent does like $100 million of transaction every week. So it needs like $100 million of economic security. And instead of, if it depends on 5 AVSs, you would say like and any one AVS can rug this AI agent. Then you would say, go and acquire $100 million insurance or economic security from each one of these AVSs. But instead, you could just take, if the restaking protocol was configurable, you would say, I'm going to take $100 million insurance on the union of these AVSs. Any one AVS goes wrong, then $100 million is slashed. Maybe the same group of stakers and operators run these 5 AVSs together. So you can start taking these kinds of combinatorial restaking, like insurance or restaking slashing, and it makes the market economics really different and very powerful. So that's another thing that I think when AVS consumption moves to not just one AVS is being used in an app, but many AVSs are being used simultaneously, what sets of new things and properties come downstream of that? I think that is another, I think, really interesting direction for research.
Thanks. Any other questions? I know we only got a few more minutes, so I want to make sure if anyone does. Otherwise, thanks so much, Sreeram, for coming and walking us through the future of AI life. I will say, like, whenever I hear life in a mathematical context, I think of Conway's Game of Life. So it's funny to see the opposite type of life in some ways. So.
This is like the